Hi everyone, welcome to today's session on long channel MOSFET, which is the continuation of our lecture series Low Power VLSI Design. In today's lecture, we will understand what long channel MOSFET is, its structure and working principles, and different operating regions, current voltage characteristics, advantages of this long channel MOSFET and what are the main limitations of long channel MOSFET, and finally we will compare this long channel MOSFET with short channel MOSFET. By end of this session, you will clearly understand why long channel MOSFETs are important for learning CMOS fundamentals. Before we begin, let us see where this topic fits into our lecture part. This topic belongs to participation in CMOS. Earlier we have discussed about main sources of power dissipation, that is static power dissipation, dynamic power dissipation and short circuit power dissipation, and after that we have discussed about MIS structure. Now we move on to long channel MOSFET, which serves as the foundation for understanding modern MOSFET devices. The concepts learned here will also help us understand submicron MOSFET and short channel effects in later lectures. Let us first understand what a long channel MOSFET is. A MOSFET or metal oxide semiconductor field effect transistor is one of the most widely used semiconductor devices, and a MOSFET is called long channel MOSFET when its channel length is relatively large, typically greater than 1 micrometer, where this channel will takes the charge carrier which decides the flow of current. Because of this large channel length, undesirable effects like DIBL, that is drain induced barrier lowering, velocity saturation, other short channel effects are almost negligible. Some important features include the current is controlled by the gate voltage. It provides stable and predictable characteristic. It is easy to model mathematically and to analyze that. It performs the basis of understanding of all modern MOSFET devices. And various application of long channel MOSFET includes analog circuit, digital logic circuit design, and all educational laboratories, research purposes, and low frequency electronic systems. Although modern chips use smaller devices, long channel MOSFETs remain extremely important for learning transistor operation. Now we will go with the structure and operation of long channel MOSFET. A long channel MOSFET contains 5 major parts, like this MIS structure has 3. This long channel MOSFET has 5 parts. One is gate, another one is gate oxide, source, drain, and body is also called as substrate. The gate is separated from the semiconductor by a thin silicon dioxide layer called oxide layer. This acts as an insulator for the device. When we apply a voltage between gate and source, an electric field is created. If the gate voltage exceeds the threshold voltage, electrons gather beneath the gate in an NMOS transistor. This forms an inversion channel, what we have seen in an MIS structure, with small positive voltage. Like connecting this inversion channel connects the drain and source. Once the channel is formed, applying drain voltage allows current to flow, and the gate voltage controls how much current flows. Depending on the applied voltages, the MOSFET operates in 3 different regions. One is cutoff region, another one is linear, also called as triode region, another one is saturation region. Each region has different application, which we will discuss next. Next is current voltage characteristics. The operation of the MOSFET can be divided in 3 regions, as we have seen in the previous slide. First one is the cutoff region. This occurs when the gate voltage is less than the threshold voltage and there is no inversion channel formation. Almost no current flows from source to drain. Therefore, transistor will be acting here as open switch in cutoff region. Next layer is linear or triode region. This occurs when gate voltage is greater than the threshold voltage. That varies depending upon the semiconductor what is preferred. Drain voltage is smaller than the overdrive voltage. Here channel is fully formed at this condition. and the MOSFET behaves like a voltage controlled resistor. As the drain voltage increases, the drain current also increases almost linearly, and this region is useful in analog switches. Third region is saturation region. When the drain voltage becomes sufficiently high, the channel near the drain becomes pinched off, and even though the drain voltage increases further, the drain current remains almost constant, and this is called as saturation region. No more operation occurs. This operating region is widely used for amplifier circuit because the current mainly depends on the gate voltage. Thus, each operating region has a specific purpose depending upon the application. Next is characteristics and advantages and limitations of this long channel MOSFET. First we will discuss about the characteristic. The various important characteristics are long channels reduces electric field effect, leakage current is very low, threshold voltage remains stable, and velocity saturation is negligible. Mathematical equations accurately describe the device behavior, which is easier for analytical purpose, and these properties make long channel MOSFET easy to analyze. Advantages: predictable operation, high reliability, better noise immunity, and easier circuit analysis, and it is best suitable for analog circuit design applications. Limitations: however, it has many advantages. There are some disadvantages. Since the channel is longer, large chip area is required, which comes into the trade-off of area and power. Even though we are focusing on power, area is getting increased in the case of this long channel MOSFET, and switching speed is slower, and parasitic capacitance is increasing. At high frequency, parasitic capacitance, it is a inevitable capacitance that getting added. They are not suitable for today's highly integrated processor. Therefore, long channel MOSFETs are mainly used for learning and certain analog applications. Now let us compare long channel versus short channel MOSFET. Here the major differences are: first, with respect to channel length. In long channel it is greater than 1 micrometer, in short channel it is less than 1 micrometer. Leakage current: in long channel it has have a very low leakage, short channel devices have high leakage current. Switching speed: long channel devices are slower, short channel devices switch much faster. And mathematical modeling: long channel devices are simple to model, short channel devices require complex model due to additional physical effects. Application: long channel MOSFETs are used in analog circuits and for education purpose, and that is for researchers, and short channel MOSFETs are used in all processors. Because of area constraint, we are not preferring long channel MOSFET, and it is used in smartphones, memory chips, and modern VLSI systems. Let us summarize today's lecture. We learned that a long channel MOSFET has large channel length and negligible short channel effect. It consists of gate, oxide, source, drain, and body as 5 devices. It operates in 3 regions: cutoff, linear, and saturation region, depending upon the threshold voltage and gate voltage. It offers scalable operation, low leakage current, and simple mathematical modeling. Although modern ICs use short channel MOSFET, long channel MOSFETs remain essential for understanding the fundamentals of CMOS technology. Thank you for the attention. In next lecture, we will discuss about submicron MOSFETs and understand how reducing the channel length introduces short channel effects and impacts low power VLSI design. Thank you once again.